So I am Atita. I'm Atita Arora, and today I would be taking you through this small journey of Apache Solr. So this is the new age search through Apache Solr topic, which we would be discussing today. And just to give a brief about myself, I'm a software professional, being in industry for about over 9 years now. And I have been working on Apache Solr since I think December 2008. And I have been working on Solr since version 2.2. So we had a lot of challenges and a lot of struggles which we had to go through when we were using it initially. So I would not go into a lot of details. Instead, would like to begin with this interesting topic today, and I hope this comes out to be pretty useful one for everyone who is present on this forum today. So I see about 50 plus folks. So let's quickly begin with this. I'll just minimize the question window as of now. And just a small request, we would take logical breaks in between. So I would try to address each and every question you guys send across. So I would be taking each and every question and answering everyone's concerns. So in case if you post a question and you do not you know see that I'm not answering the question, please wait for some time before I take the logical break. Okay, so we have about 60 minutes. So let's make the most of it today. So what we are assuring you that what you will learn today is that why exactly the search engines are required in any enterprise grade application which has been used across today. What are the objectives and challenges of the search engine, and what and how is the indexing and searching handled in Lucene. Again, we would be discussing a little bit of Lucene as well in today's session, because Solr is, it gets most of its features from Lucene only. So then we would step into Solr. We would be discussing the architecture of Solr. We would be discussing how the near real-time search is supported through Solr. How is the search enhanced through Solr? We would be learning about Solr Cloud, and we would also see a little bit of how we can leverage the Solr capabilities with Hadoop. So a quick question for you guys. Everyone seems to be here for a purpose, and everyone wants to learn about Solr. And we know that Solr is something which enhances the search functionality on any web applications. So a very simple question, guys, like why do we really need a search engine? What do you guys think? Any thoughts? Anyone from the attendees? Why do you think we would need a search engine? Imagine if you have to look for something and the Google is not there. Okay, so we have couple of answers from, okay, Puneet says it makes life easy. Couple says it's search files, images, PDFs, saves time, relevant information. Wow. Quick find a product, information, okay, to get the information quickly, Dinesh says. Keyword-based searching and speed, get faster results, Deepak and Manish says. Fabulous, guys. You guys really know that why we all are here. So just to sum this entire thing, yes, Manoj, save time as well. So yes, just to sum up what we have just shared. So most of them were that we are trying to find the search results from the free text, and we're trying to get the quick results. And the other one was the relevancy. So if we want to like narrow down the answers which I have just received on my answers window, is two things. The first one is speed, and the second one is the relevancy. Anyone who has any other point why we would need a search engine? I narrow them down to two things. first one is the speed and second one is the relevancy. So I say that we would need the search engine to get the results faster and the relevant, the accurate results. So speed and relevancy are two things. Solr or any search engine for the matter of fact is popular. So we would need the search engine to give us the speedy results, the quick results, and the relevant ones, right? Everyone with me? Yes, no, maybe. You can send in these smileys as well. So I like it. Manoj is using these smileys. So you can, instead of typing in yes, you can send in the smiley. Yeah, good going, Deepak and Dinesh. Okay, so, all right, great. Yeah, that works as well. So just to, give you a small example of this snapshot which has been taken from a very popular e-commerce website. So this is a snapshot wherein we are searching for the quad-core mobile phones. So this is how more or less any e-commerce website's interface looks like. So we have the free text search box here, the search box wherein you can send in your free text query, and along with that query it would give you the auto suggest the suggestions, like are you looking for the quad core mobile phones with the KitKat OS, or the Sony mobile phones, or the quad core mobile phones with the 4.5 inch screen. So these are something the suggestions which are given on the basis of the most used search strings by the other users. So these are basically the ways by which it enables, or this gives you the nice experience that you don't have to type too much. You can just pick out one of these suggestions if it suits you. So along with that, on the left hand side, if you see that it provides you few filtering criterias as well. Like as of now, we are looking for the mobile phones data. So we might want to categorize the mobile phones on the basis of the price range they might belong to, the brand they belong to, or the operating system, or maybe the screen size, or maybe the material of the body, or maybe the SIM preferences like a dual SIM or the single SIM. So there could be several filtering criterias which we might have. And on the right hand side, if you notice, these are few of the related products which are related to the product which you might be looking for. And in the center, in the middle of the screen, if you notice, we have given the search results. So the search results basically consist of the name of the product, the star rating, maybe the consumer rating, which category does that belongs to, what is the discount, uh, you know, discount which is offered on this particular product, the price range, and maybe the few of the features, like any site might prefer to list the 5 key features or the 5 most hot features of that particular product. So this is how each of the product is listed. So from here, if you look into, um, there are few things which we have gathered, that we need a text-based search. Unlike any normal RDBMS client, we do have to follow a particular semantics, like a field name or the name equals to maybe the name of that product. The feature should be so and so. This is how the price should be. It should belong to this category, like price should be maybe more than 3,000, less than 5,000. So you would have to follow a particular semantics to search a particular product in any traditional RDBMS. Instead, on the contrary to this, if you are looking for such kind of feature which enables your website to have a free text search interface, this is something you should go for. So any e-commerce website or any web application, for the matter of fact, which is wanting to enhance the search experience of the users of that site, would want to have this feature that they would like to support a free text box, free text search box, which can let user type anything, and it would basically generate a complex query which is sent to the system, and the respective results are being fetched. Along with that, I would also like to have the features which might want to narrow down my search results to few of the products, so that I can quickly list, or I can quickly choose from. So these filter criteria are called facets, which you see on the left hand side of your screen. Along with that, there might be a chance that you might be looking for a different search string, but it is related to something you might be more interested to look into. Like I'm looking for a quad-core mobile phone, but I see on the right-hand side, the related products are listing a tablet, which comes in the same range as much as I'm wanting to spend on a mobile phone. So I might think that maybe, going for a mobile phone in that price range, I might go for a tablet. So this is something which might enhance the user experience further, as it can give you the suggestions on the basis of the popular products which belong to the kind of features you're looking for as well. And along with that, it is listing out all the search results in the form of a document. Like all the information I would want to see in one glance about a product has been listed here. So I can quickly see that which brand is it, what is the consumer rating, how much discount am I getting on this website, what are the key features, like how much is the screen size, how much is the camera pixels, if it's a dual sim phone or not, or if the mobile phone body is suitable to me or not. So I can get the quick insight of the product here itself. So this is the reason anyone would want to prefer a search engine, that it makes our work easier. Plus, it gives me the speedy results and the relevant ones. So I get to see all the relevant results at one go. And they've been, they can be compared, they can be sorted as per my choice. Agree, everyone? Anyone who would like to add something to this? Okay, so how exactly it should be? So how exactly should a search engine be? So if you need a storage engine to search records or the documents based on the free text keywords, it should be able to support features like, it should be, first of all, it should be optimized for the faster text searches. You should be able to support free text, and it should be faster as well. Anyone who has worked on any traditional RDBMS interfaces, they would know that the numerical and any searches which are related to any numbers, they're pretty fast on search interfaces. But you have to look for any text related searches. There are very limited number of operations available. Plus, they're very slow as well. So most of the time on such websites, we look for the products, and they have been searched through the free text. So free text, when I'm saying that a user can type in anything, like taking an example from an e-commerce website, maybe I can say that a silver watch with a blue dial. So this is an example of a free text. So I'm typing in anything I'm wanting. I'm not saying that dial equals to blue and the wristband should be silver. I'm not really specifying any criterias, but I'm just typing whatever comes to my mind. So along with that, my my search engine should have a flexible schema. So schema, I hope you guys do understand. The schema is the way my information has been structured, what all fields my record is going to contain, and in case of a document, how many fields or what all fields my document is going to have. So imagine, again, taking an example from an e-commerce website, imagine if I have to index say a mobile phone data. I would need fields like the brand, the screen size, the camera pixels, the SIM preferences, dual or single. I might say price as well. I might say the phone body. I might say the OS version. So my fields would be different. However, imagine if I'm listing, say, a book data. I would say my document is going to contain the fields like who is the what is the title of that book, who is the author, which language is it written into, what type of binding it has, and if it is available in my country, what is the price, what is the user rating. So Do you see the difference? Do you see the variation in the fields? Do you see how the documents are being recorded? They're completely different. The fields are not going to be similar. There is no uniformity in the kind of data which has been stored for these two different products. But my search engine should be able to ingest data for a mobile phone as well as a book, and it should be able to store both of these informations without any hassles, without me having to change the schema. Is that fine, guys? Is that making sense? Yes, no, maybe, smileys. Along with that, it should be able to support the sorting of the documents as well. Like I should be able to sort them on the basis of the features as well. So like I would want to sort, say, on the basis of price or on the basis of something else. So that should be supported as well. So sorting is very important because, I mean, by any chance, if you might have used any e-commerce website, the first thing anyone would want to hit is the price range from low to high. I'm sure you might have also tried that. I mean, I do it all the time. When I'm looking for any product on the e-commerce website, I do it all the time. The first thing after searching is arranging my product list or the search results from price low to high. So this is a normal human tendency. So fourth feature is that it should be web scalable. That is, imagine if you are looking or catering to a web application, you can expect more number of reads and less number of writes. I mean, the data is going to be fed into from a different route altogether. Your data would be, read more number of times instead of being written more number of times. So it should be optimized to cater to huge number of read requests. Along with that, it should be document oriented. I mean, each of the fields or each of the information pertaining to each of the product should be listed in one single place so that there is no hassle in looking for the information whenever I'm trying to construct a UI. Is everyone fine with it? Any other feature you feel a search engine should have? I mean, this is more or less a very exhaustive list. So this is another example which we have taken from a travel website, that if you're looking for, similarly, I mean, we were looking for the mobile phone data. Similarly, if you're looking for anything on a travel website, if you notice on left hand side, the criterias, the filter criterias or the facet, I mean, in technical jargon, if I really have to call them, these are the facets. So facets are the filter windows. So these have changed. The price range is one of the filter criterias here. The star rating is one of the criterias here. What is the like website rating? What is the location? Like in case if you're looking for any destination or any particular hotel in a city, right? So this is how the perspective really changes. So my search engine should really let me control all of these features so that I can have a nice user experience. Agree, everyone? I'm sure this is quite generic things you might have seen in your real life as well. So coming back to this, we have been talking about Solar, but then as I introduced Lucene as well in the beginning, I said that everything which is there in Solar, like 85% of the features of Solar, are based out of Lucene. So what exactly is Lucene? Does any one of you recognizes this guy in the insat? Dough cutting? Anyone who recognizes him? I'm sure a lot of you would. Okay, Anita says no. Okay, Dinesh says yes. Cycle says big data Hadoop. Absolutely. So this is the guy who was created Hadoop as well. So this is the guy who has created Lucene as well to begin with. So he named Lucene after his wife. There's a very interesting story. In fact, had this been my real class, I would have actually, shown you this video where this guy has been talking about how he, evolved the name of Lucene. So this is a very, very interesting story. In fact, you can find that on YouTube as well. So Lucene is something which, came as a in-house project, and later on it was donated to Apache and it became open source. So it's a very powerful Java source library, which lets you easily add the information retrieval or the search capabilities to your web application. Trusting, if you're wanting to trust the capabilities of the Lucene, you can check this link. I think I have opened this link somewhere. Yeah, this is the one. So these are the giants who are using Lucene. So you can get huge giants like AOL, and you have Apache, you have Apple here, you have Apache here, you have Netflix here, you have LinkedIn here, you have Twitter here. So these are few of the giants to name who are using Lucene, and they are using the capabilities of Lucene to enhance the search experience of the users of the website. So this is okay. Anita has a question here. Is Solr using this library? Yes, Anita, it is. In fact, when we move across to the architecture of Solr, you would see how excessively this Solr is using Lucene. In fact, the core features of Solr are being extended from Lucene only. So the basic indexing and searching has been rendered from Lucene. So it's a very, I would say it's heart of Solr. Okay, so it gives you the scalable and high performant indexing capabilities, and it's very powerful, accurate, and efficient search algorithms it has, considering that a lot of big giants have already been relying on it and have been using it. Obviously you can trust the capabilities. Plus the biggest advantage it has is that it gives you the cross platform solution. So, which means that though it is based on Java, you can use it in .NET, you can use it in Python, you can use it in PHP. So there are implementations which are available in other programming languages as well, which are index capable and compatible. So how does that really works? I mean, what makes it so fast is what my next topic is. So imagine, guys, if you have to look for any information, considering that we have this example that we have three documents. The first one says, I like Edureka courses. The second one says Edureka teaches big data courses. And the third one says Edureka helps learn new technologies easily. So imagine if you have to search for maybe a single string, maybe you have to search for data out of these three files, and you have to write any program, or you have to use, say, the traditional RDBMS. How is it going to be like? You would have to flat file scan each of these documents, right? Is that correct? Anyone who differs? Anyone who has any other way? Yeah. Okay. So we are saying that yeah, Saikat, that's right. We can use NoSQL as well. So Solr is something which can be used as NoSQL as well. So in fact, that solution is correct. That is what I'm heading to as well. So we are basically defending that we should not be using the flat file scan. Instead, we can use Lucene. So how does that really do? Is that it maintains the indexes, and how that manages the indexes is that we are indexing the data of all these three files in one single file, which is called the indexes. And how is it manages that? Each of the key terms from this document, from each of these document, they are being maintained as the table and the document reference, like Edureka, and we are maintaining the reference for the documents which contain the word Edureka. So Edureka is there in D1, D2, and D3. So I store D1, D2, D3 as the document reference. Similarly, courses is there in D1, D2, D1 and D2, that's right. Teachers is there in D2, big is there in D2, data is there in D2, helps is there in D3, so on and so forth. So I break up each of the stream of data which is there in each of the document into the tokens or the words, and I'm storing them as key value pairs, right? So I'm basically storing the word and the document reference along with. So what happens in this case is, in case I have to look for, say, the word data I was saying, I don't have to go through each of these files. In that case, I don't have to go through and read D1. I don't have to go through and read D3 or D2 for the matter of fact. I can simply skip this step and I can simply read this index file. What that does to me is that instead of wasting my time in flat file scan of all of these three files, I just spend my time in parsing this one file, and I simply get the results here. That data, the word data, was there in D2, or similarly the word Edureka, that was there in D1, D2 and D3, all of these three documents. So that's right, Chakradhar. This process is called TF-IDF, that is term frequency inverse document frequency. That's right, Saikat. This is how MapReduce works as well. That's absolutely fine. I mean, these all of these big data technologies are somewhere, closely related to each other. They're basically using the same technique in most of them. So I hope this is clear to you guys, that how that makes the searching faster. So the process of indexing does converts the data into this format. This index file has been generated from the chunk of data which you uh, give to your Solr server. So in the process of indexing, it breaks up the data into this format and creates the indexes file, which is then being read by the search procedure. Okay, Kapil has another question, a very interesting one. What if I misspelled Edureka to Eduke only? Will it search? It will definitely search, Kapil. And we have, again, this is what Lucene probably would not be able to achieve. If you misspell the word, Lucene would not be able to correct it. But Solr has got the spell checker search component, which will correct your search string, and it will ask you that did you mean Edureka, or did you mean anything which is also close to the word Edureka as well. So it can suggest you, and then you can select that yes, I meant Edureka, and then you can basically look for the right results. Yeah, that's right, like a Google search. So that is the spell checking feature which is there. It's called a search component. So we teach you how to configure that on your Solr instance. Okay, Chakradhar has another question. Will keys be hashed? Uh, I'm not sure what does I mean, how do you want to say it will be hashed? You mean will they be encoded in some format? Is that what you mean to ask? Okay, yeah, yes, you can choose to do that as well. Normally, it is not done that. And normally, whenever the data has been indexed, it is not stored as the plain text file. It is anyway encoded in a different format altogether. So if you basically look into any of the index files which are being generated by Solr, like over here, if you look into, so like this is where I have stored the collection. So if you look into the data folder, this is where my indexes are being generated. These are anyway the different formats altogether, how these indexes are being stored. They're anyway encrypted in some way which you cannot, I mean, which are not human readable. Does that answer your question, Chakradhar? Okay, all right. Okay, another question from Bisma is how Solr achieves better results than a traditional search engine like verify nee. Okay, it's a Verity, I think, and Idle. I am not sure. I've not really. I've heard of Verity, I think, but not really have heard of Idle. So okay, the traditional search engines, as I just explained, Bisma is yeah, Verity K2. Okay, so what I was trying to explain over here is that we have very limited capabilities in terms of text searching with the traditional search engines. So if they're not using, they might be using the traditional indexes which are being generated on, say, Oracle or MySQL. So the procedure of creating the indexes is altogether different in case of Lucene and Solr, and plus it is faster as well. So this technique is something which basically creates the differentiation. Is that fine, Bisma? Another question from Deepak, is it individual words are indexed or we can index multiple words too? So Deepak, just to answer the question, this is mostly the configuration based. So you can choose how do you want to basically break the tokens. So each of the token has been indexed and you can choose how these tokens are supposed to be created. So you have various algorithms and you have various tokenizers which come handy in the uh, distribution itself. So you can choose the way by which you would want to break the tokens. So that's entirely on the user's choice. Is that fine? Does that answer your question, Deepak? Okay. So let me just move ahead. So we have the way in which we are writing the indexes data. How is it done is, so you can think of a document as a record which has been fetched by a traditional RDBMS you know, table. So like you search for a table record from a table. In the similar manner, we search for a document from a collection. So a collection is a table, a document is a record, and a field is a column. So just to strike the similarities. So document is nothing but a record, and like a column, like a record that consists of several fields, several columns. In the similar manner, we have a document which has several number of fields, right? So these fields, every time you pass in a document with the numerous fields in there, that goes through the process of analysis, wherein it basically breaks in the tokens as per the choice of your algorithm. So you can choose the standard ones. You can write your own as well. It's completely extendable. So you can extend the existing functionality. So you can write your own way in which the tokens are broken. So then these tokens are basically, they go through the process of index writing, and the indexes are being created on each of the fields, and then this data has been dumped as the indexes on the directory. So this directory could be the file system. This directory could be the HDFS as well, in case of using them with big data technologies. So these are the main classes which are used in case when we are indexing the document using the Lucene. So document, field, and analyzer, index writer, directory, these are the classes. Just to give you the context of if you have to write a program in Java to index. Similarly, we have the query parser guy who's the magic man. So every time you send in the expression or maybe say a free text query that is been read by the query parser, which again performs the analysis on this query which you have given to the search given in the search box, and from this query, and after creating the text fragments by analysis, it would generate the complex query as in whichever type of query parser you have chosen. And then this sends across this complex query to the index searcher and to the directory, and the search results are being returned in the similar format. So this query parser basically translates your expressions from the end into the arbitrarily complex query, which is then read by the index searcher and has been sent to the Solr, and the respective search results are being fetched. Is that correct, guys? Is that right? I mean, any confusions here? Anything you guys did not follow? Okay, I'm seeing a few questions here. So let me just cover a few more topics before I take up these questions, because we have a lot of slides to cover. I hope you guys don't mind that. I would not leave today's webinar with any of the questions unanswered. So would like to cover a few topics before I answer the questions. I hope everyone is fine with it. So we have been discussing about Solr. So what exactly is Solr? So Solr is the open source enterprise search server and also the web application. You can use it as the web application as well. You can use it as the search or the index server as well. You can use it as the NoSQL server as well. So It uses the Lucene's search libraries, and it extends the features further. Along with that, it exposes the Lucene's Java APIs as the RESTful services. So you can simply hit the APIs directly from Solr. You can put in the documents in the process of indexing. They are supposed to be they go through the process of analysis and are being uh, indexes are being created on that particular document, and that has been dumped or stored into the directory, the index directory. So these documents can come across in XML, JSON, CSV, or binary, and they can be sent across over HTTP as well. They can be sent across through the curl request as well. So you can also query them through curl. You can also query them through HTTP GET and receive the similar XML, JSON, CSV, or binary results. So as in whatever your choice is. You can also get results in PHP as well. You can get results in Perl as well. So this is absolutely a choice. So it supports a lot of formats of data. So that's one good thing about it. And it gives you a very nice admin console as well to see how things are basically flowing around. So what are the key features of Solr? So the first thing which we have been discussing is that it gives you the advanced full text search capabilities, which means that the text searches in any format is being supported, free text or the full text or any type of search which is related to the text or the strings has been supported completely. Then along with that, it has been optimized for the high volume of web traffic. Like if your site is expecting to have more number of reads than writes, definitely you should go for Solr. So it is optimized for high volume web traffic. It exposes the standard based open interfaces like XML, JSON, and HTTP. It works on these standard interfaces. It provides you with a very comprehensive HTML interface for administration. We would be taking a small demo, a basic demo for reading and writing, wherein I would give you the idea of how this administration console looks like and how you can push in your data and you can retrieve the data from that admin console as well. So we would see that during the demo. You can also monitor your server stats, which can be exposed over GMX for monitoring purposes, for administration purposes. Another thing is that it gives you the capability of the near real-time indexing and searching, which is adaptable with the XML configuration. So you can change it, you can change the behavior, you can choose that, how quickly do you want to see your results. So it gives you like the near real-time search and the indexing capabilities. So, and that too is absolutely configurable. Along with that, it is linearly scalable. Like you can add in the memory similarly in the similar format as Hadoop. And the auto index replication is there. You can choose the replication factor, and that with that using that factor, the data would be replicated in case of any disaster. The replicated data can be used to uh, for recovering. And also it provides you with the auto extendable plugin architecture. We have a lot of other plugins available. Like one of them is to read data from different file formats. So one of them comes integrated in Solr as well. You can add more plugins as well. So this plugin is called Apache Tika, which comes along with Solr, which lets you read data from different file formats. Is that fine, guys? Let me take few questions here before we move on to the next topic. I see a lot of questions are there. Okay, okay, this has another question. Does it just text-based or can Solr internally look for metadata tag-based indexing? So if you mean that you want to index the HTML data or something close to that, yes, it can do that as well. Okay. Okay. Ravindran has another question. In a typical Solr search architecture, where the document is usually stored, it has been stored on the file system, Ravindran. The Solr uses NFS files or MongoDB or HDFS to store the original document. So it is not really using, I mean, you can choose to store the indexes on any type of directory. So the directory which we just saw in the diagram where we were showing how the data has been indexed, we had this one component called directory. So you can create the instance of the directory object by choosing the type of directory you're wanting to store the data in. So it could be HDFS as well. It could be NTFS as well. It could be a RAM index directory as well. So wherever you're wanting to store the indexes. Okay. I would have really wanted to share some more business cases, Ravindran, but due to the time, because anyway, we are supposed to be ending the session at 10:30, and I'm pretty sure that I would not be able to cover absolutely all the slides. That is why I'm kind of rushing through them. So I would definitely would have shared some more business cases. In fact, in my classes, I definitely encourage everyone to share the business cases from their domains. Plus, I have a lot of business cases. I generally discuss a lot of case studies as well in my classes. Okay, Dinesh has another question. What are advantages of Solar over MongoDB? Okay, so MongoDB again is similar to this as well. So they both run on the similar, I would say similar principle of NoSQL as well. But again, with Solar, you can have joins as well. You can join the queries. MongoDB would not really let you do that. Okay, Nishit has another question. Does having large number of fields in a document slow down the indexing procedure? How do you optimize it? Okay, so yes, it would definitely affect the processing because you would have to process more number of fields. So again, to optimize it, I would say that you can basically write a program by way you can index or you can analyze the fields in the custom way. I mean, you can write that on your own, or I would say that I mean, you would need more processing power in that case. That can also enhance or that can also enable a quicker indexing procedure. So if you have more number of filters or more number of stages of filtering, definitely that would slow down the process. But that's only the indexing procedure that is going to slow down. So you can probably index the data whenever you're experiencing less number of hits. So you can give more processing power to the indexing procedure altogether. Yeah, that's right, Saikut. So we come down to the Solar's architecture here. So this is what I was talking about, Anita, when I was saying that you would see that the huge chunk, the majority chunk has been occupied by Apache Lucene. So all the core searching, the index reading and the searching capabilities, along with the analysis capabilities, along with the indexing and the index writer capabilities, they all are being rendered to Solar from Apache Lucene. So this is how they've been extending in terms of adding additional and the advanced features. So we have been speaking about that it exposes the Lucene's API through restful services. So this is how these services are being exposed. Like the admin console has been accessible through the slash admin, the slash select, and the slash spell. So this is where my spell checking component has been enabled. So the request handler is the guy which basically takes up the request in the way like a proper you know how should I tell you that like a request can be sent across to this like a localhost 8983 is the default URL, which you would definitely hit in case you're accessing the Solar. So if you say that slash admin, it would take you to the admin console. If you say slash select, it would take you to the querying console. So this is how this entire thing goes about. So all the capabilities are accessible through this. So the request handler is basically the way each of this request is going to be handled. So there is a different implementation altogether which has been written with respect to each of these requests which are received on these particular REST APIs. So these search components also form a part of request handler. Like they can be used individually as well, like they can be accessed individually. You have the configurations which are available to monitor and control the behavior of each of these search components. Like how would you want to choose the way this query search component to behave? How would you want this highlighting to behave? How would you want this spelling to behave? So on and so forth. So then you have the clustering and more like this, and faceting and debugging. These are few of the search components. However, no one stops you. You can extend the behavior. You can create your own search components as well, which can help you achieve any particular business purpose. So all of these configurations are available in Solr config XML. So if you look here, we have listed, in the middle, two configuration files, which basically controls, I would say, 85% of the behavior of the Solr instance. The schema.xml, which basically lets you control the schema of the documents which are coming across in your Solr instance, and the Solr config XML, which basically lets you configure these request handlers, the search components, and all of these advanced features like faceting, filtering, search, caching, highlighting, query parsing, and analysis. So you can control almost all the advanced features through this Solr config XML. Along with that, you have the request writers, which are also present in this architecture. So request writers are the ways in which you would want to present your responses. Like how would you want to write your request, and how would you want to get the response, like what all formats. So it could be XML, binary, JSON, it could be Python as well, it could be CSV as well. Then also the update handlers, which are basically there to control if you are wanting to send in the updates on the already indexed data. So you can send that in the XML, CSV, or binary format, in the JSON format as well. So you can send in the updates in this format as well, which are basically there to update the already stored data. The update processors are the processes which act on these update handlers. Whenever you are updating the data, you can choose to maybe encrypt the data at the time of creating the indexes. You can also do a different type of logging altogether, or different or the custom indexing as well. This is another thing which I would like to discuss here. I've just given you the reference of Apache Tika. This is also more pertinent to the update handlers. Like I might want to send in the a Word document or a PDF document. So my Apache Tika, which also comes as the part of update handler, it basically extracts the data the from a particular file format, and indexes that particular data in my Solr instance. So that entire data has been also indexed, like data which has been picked from any other text file or CSV file. Then we have the data import handler as well, which is also a type of a request handler, which you can configure to be accessible by any say slash data import. So you can configure that on that particular REST API, like slash data import, and uh, you have this another configuration file which can let you import the data from RSS feeds or any traditional database you would like to bring into your Solr. So this is something which can also be achieved through Solr. So you can configure this data import handler, which can import the data from different sources. Then you have the index replication as well, which is basically there to make sure that the data has been replicated as per the replication factor, which has been specified in the Solr config XML. And whatever the replication factor is, that many number of copies of data has been maintained for that particular data set. Is that fine, guys? We have few questions meanwhile. Okay. Okay. Manish has a question. Does it do data analytics as well? Like most used text in search, etc. Yes, Manish, you can definitely have such kind of implementation. So we do have this plugin which gauges the popularity matrix of each of the document, like which is the document which has been most searched. Like you can calculate another matrix which counts like how many times a particular document appeared in the search results. So that basically monitors the popularity index of each of the document. So such kind of analytics you can definitely do. Okay, are there any vendors who distribute Solar? Ravindran is asking. So Solar is open source, Ravindran. I mean, there are vendors who are extending the basic functionalities. So there are Hortonworks and LucidWorks, which provides consultancy in such applications which are using Solar. So otherwise, Solar is open source. You can happily download it and you can start using it right away. So it's as simple as that. It's just about executing a shell script, and you get to go. Okay, Kapil is asking, index replication only replicates indexes, not the files. Yeah, that's right, Kapil. Only the indexes are being replicated to support the search results. Okay, Anita has another question: is data moved physically to Solar? I think you're asking, or only creates indexes on the remote documents? Okay, physically to Solar. Okay. Whenever the document has been read from any of the sources, like I'm talking about reading the data from the traditional RDBMS or from the feeds, the data stays wherever it is. We're just maintaining the indexes at our end. The data is not really moving. Okay. Can we install Solar in Windows? Yes, you can do that, Manish. So you have the distribution available for Windows, Linux, or whichever type of system you're using. Okay, is it possible for doing custom ranking in Solar? Rinky is asking. Yes, that is possible as well. So you can override the ranking mechanism. So you can definitely do that. So you can write in your own class which can define that how do you want to let the documents rank, and instead wherever we are defining the ranking search component, you can define your own class. You can give the reference of your own class, and the ranking would be calculated on the basis of your logic instead of the default logic. Okay, Ravindran says, I'm sorry, I missed the distribution answer. I'm saying, Ravindran, that it's open source. Solar is open source. However, the consultancy of various other formats are being provided by Hortonworks and LucidWorks. Okay. Nishit says, can we update indexes for a partial set of documents? Yes, you can do that. Okay. So let me just move ahead. I'm already running out of time. Is it fine, guys, if we can extend for, say, 15-20 minutes? Will that be fine? I'll try to wrap up things as quickly as I can. Okay. Thank you so much. So this is another way. What is the procedure of search? Like the query type basically defines that what type of query are you searching. Like you can define the handlers, the request handlers here. So more or less, whenever you send in the request, it has been given to the request handler. You can choose to define the definition type, the way your request should be read, how it should be broken. Like this act as the query parser. So this query parser is the guy which breaks the free text into the logically framed query, which has been sent across to Solar for search results. Then the query field is something which act as, like you used to say that select name and department and say the age from the employee table. So this QF is going to specify that what all fees are we wanting to query, right? Then this start is going to specify like from which record number are you wanting to read the data from. and how many rows are you wanting to read. The filter query is a little different from the QF. So QF is that we are selecting only those fields from the data set. However, FQ is basically performing the additional filtering from on the data which has been fetched from the index store. So these basically does the little more processing on the results which have been fetched. So more filtering has been done. And WT specifies the writer type, like you can choose in which format are we wanting to read the data. So this is how the near real-time search has been done, which means that as soon as you push in a document for indexing, and the next moment you search for that document, that is available for in the search results. So this is basically controlled by this commit property, AutoSoft commit property. Anyone who is aware of MongoDB would know that something similar to this is also available in MongoDB as well. So this is the time wherein you can specify that in 100 or maybe 1000 milliseconds, this particular document would be available and it would be synced up with the other indexes and would be available in the search results. So we would take a quick example of that as well. Okay. Similarly, we have the real-time get, which basically enables you to fetch a document with its ID. So real-time get is like as soon as you push in a document, and if you're wanting to fetch the document using its ID, you can do that by uh, retrieving it from its unique key. So this is primarily very, very useful whenever you're using Solr in the NoSQL mode, NoSQL data store mode, and not just as the search index. So something similar to like we used to do in Oracle and MySQL, like we used to fetch a particular record by its unique ID. So we can take quick few examples on that. And do you guys want to take a quick demo on this, or should I just move ahead with the topics and take the demo in the last? What do you guys suggest? Okay, demo first. Okay, all right. I'll go with that. So I quickly would want to show you. Okay, Solr. And imagine I've just downloaded the distribution of Solr 4.10.4, and I have just unzipped the distribution here at this location, and I simply do this, start. It's as simple as that, Ravindran. Absolutely no licenses or anything per se is required. So Dinesh said that we can take the demo at the last, but looking at the poll, I mean, people wanted to see the demo first. So I hope you don't mind that, Dinesh. Okay, all right. So as soon as this has been done, it is going to read all the schema.xml and the Solr config XML and all the configurations. And it simply lets me access it. So this is how my admin console looks like. Um, Increase the window size, Anita says. Are you not able to see the window, Anita? Any issues with it? That was just the console. I mean, okay. So this is how the admin console looks like. So you have the dashboard, which tells you about all the JVM properties and stuff, which tells you about the system properties as well. It tells you about logging. So we have discussed about the logging. So how do you want to really do that? So it tells you about all the components which have been configured, and if it wasn't able to, figure out any component, it would throw you an error here. You can choose the logging level here as well, like if you want to see the info or the warn logs. This is the core admin. So core admin, the core is the collection. So core is not really the literal meaning. Core means the collection. So I have these many collections, or just to understand it better, I have these many number of tables, like in a traditional database, I would say. So I have these many cores here. I can further add any core from here, but for that I need to have this directory present in my Solr folder, and I need to have this configuration and this data folder in place. And as soon as I refresh the screen, I would be able to see that core added here. So it is going to list out all these things here. Like if I'm wanting to optimize this, or if I have made any configuration changes, I can reload this core as well. If I made any subsequent changes here which are not supported by Solr, this particular core is not going to be loaded. I can also swap it, like if I have enabled the replication here and I would like to recover it from the replicated core, I can swap it and I can make the other replicated core as the one who's going to receive the request on behalf of this. I can rename it as well, and I can unload it as well, as in how it is required. These are the Java properties, again pertaining to this particular Java instance. This is the thread dump. This is where I can select each of this core, like I'm wanting to use this particular core or this particular collection to use the data from. This is going to tell me what is the version, like how many times I have changed the data on this. This is going to tell me that how many documents I have, what is the heap memory and stuff. Okay, this is the analysis way. Like if I'm wanting to see that I have so and so many fields on the schema.xml, how is this going to analyze the data which I sent across? So it is going to list out all the properties. So this is how I can configure my data import handler. Like I have configured, I think on this one. So this is how my data import is going to look like. Like I have configured a data import handler, like importing the data from a MySQL table. So I can configure this like this. So this is how it is going to look like. I'm simply going to say execute, and it is going to dump all the data from the MySQL DB collection to this particular collection. It's as simple as that. No need to write any complex scripts and stuff. No code as well as required. This is where my documents can be pushed into. Like just to give you an example of how a normal document is going to be indexed, like I say webinar 8 and I say title is new age search through Solr, and I say submit document. Status 0 means that the document has been inserted successfully. Now this is the query console. So if you look here, this is where my request handler is sending all my requests to. So select is the guy. By default, this is the star dot star, which means select star query on that particular table. FQ is the guy which does the filter query. Sorting, if I'm wanting to have any type of sorting on my particular uh, you know result set. The start and the end. The start and the number of rows I would want to see. Field listing is how many fields am I wanting to see. This is different from the QF guys. Okay, so field listing is fetching all the data, but I'm just wanting to see these many fields. And this is the writer type. So you can see the results in the JSON, XML, Python, Ruby, PHP, and CSV format. So for now, I'm just wanting to see the results in the JSON format. So I say that I'm looking for ID equals to webinar 8. And this is the guy which I've just pushed in. So if you look here, I've got this thing. So these are the additional fields which I've configured for each of the documents. Just to maintain, if I make any changes, this version key is going to be changed. Is that fine, guys? Any questions on this? This is as simple as that. However, if you're wanting to see, I say I'm looking for simply the search. So I've configured a default field here, and I can search my document through this as well. So all the documents here, which basically, had the word search in the body, they're going to be listed here. Is it clear, guys? It's as simple as that. It's very simple, isn't it? So can we just resume back to the presentation, guys? Let's cover a few more topics before we disperse for the day. So I'm not going to take any more time. I mean, anyway, I have extended for 7 minutes. So I'm not going to take any more time, and I'm just going to wind it as soon as I can. So another important thing is the Solr Cloud. So Solr Cloud is basically the newer, which is available in the newer versions of Solr after version 4.0. Solr Cloud was made available. So this is something to support the distribution search functionality in an application. So this is something which can help you set up a cluster of Solr servers, and it can help you achieve the fault tolerance and the high available Solr servers. So indexes are always available. In case any one of them goes down, there's another one which can take the place, or which can take up the request on behalf of that server which has got down. So it's a very flexible distributed search and indexing mechanism without having to have a master node or allocate nodes, shards, and replicas. So this does all by itself. So how it achieves that is that instead of using the master or something similar to that, it uses the zookeeper guy. So zookeeper is the cluster manager guy, which reads and maintains the configuration, and as per the configurations which we have provided, it is going to manage all the data. So anytime you send across the data, the zookeeper guy is going to figure out that which server this guy should go to. So this is where my zookeeper is going to sit, and this is the architecture of the Solr Cloud. So this is the centralized configuration management. All the configuration files are being read by this zookeeper. I'm preferring to have more than one instance of zookeeper as well, just to ensure that in case zookeeper goes down, I have another one to take care of that. So this is where my overseer as well is going to reside into. So imagine I have millions of documents and I have millions of users. So considering the first case, the millions of documents are there which are supposed to be indexed through the Solr Cloud. I'm going to hit a REST API, which from where I'm going to send the request for indexing, which can come into the XML, JSON, or HTTP format. As soon as these documents hits the main server, by load balancing, it is going to assign either server 1 or server 2 to me. So just to ensure that we understand these terms clearly, we have, if you notice, we have few key terms here. The leader is there, the replica is there, the replication is there, and the sharding is there, right? So just to understand these, the leader is the guy who has the right control of any particular shard. So just to understand what shard is, before that, please understand, I mean, I hope you must have understood by now, a collection is a search index which has been distributed across multiple nodes with the same configuration. So we have said that collection is like a table. So imagine what shard is going to be like. A table has been distributed in small chunks. The data of that particular table has been distributed in small chunks, and that has been placed on different nodes. So these chunks are called shards. The small piece of that table data is called shards. Okay, so sharding is a logical slicing of that particular collection data, which has a name and it has a hash range associated to it. It has a leader and it has a replica. So what leader does to a shard is that it is the guy which has got the right control on that particular shard. So we can have several replicas which can read from that shard, but we just have one leader who can write onto that shard. And this is achieved through the process of replication, which makes sure that whatever the replication factor is, we're going to maintain as many replicas of that particular data. So every time the leader is going to write something to this shard, like any new document which is coming across, and we are hitting a particular node. So a node is nothing but a JVM process of that Solr, which is bound to a particular port number, 8984 in this case and 8985 in this case. So this is counted as node 1 and this is counted as node 2. We have Solr web application which has been deployed on each of these. So I can run multiple instances of Solr as well on a single machine by binding them to a different ports. They would act as different nodes, and I can enable the sharding and the replication factor of 2 so as to achieve this kind of structure. Okay, so every time you push in the data, that has been written by the leader, and the copy of that data has been sent across to replica, so as to make sure that if anyone is, because replica is the guy who's going to basically serve the read request. So this data should be synced up with the replica so that the consistent data can be sent across to the reader. Is that fine, guys? In case this leader node goes down, in that case, this zookeeper is the guy who has the control of the leader election algorithm as well. So this guy is supposed to do the centralized configuration management. All the configuration is supposed to be read by this guy. Along with that, it is supposed to manage the cluster state, that it should be highly available. None of the nodes should go down. In case the leader has gone down, this is the guy who controls the leader election. Okay. As soon as this is done, immediately a new leader has been elected, so that the writing of data should not be affected. Is that fine? So this is a very highly available architecture, which gives you the fail-safe feature to your application. Similarly, the reads are also being distributed. So every read request has been given to the replicas, and every time you have a write request for the document, that has been redirected or delegated to the leader. Is that fine, guys? Any questions on this? Similarly, we have been reading about that how we can leverage the Solar's capability with Hadoop. So we know that if you have a huge chunk of data in your application, you would want to optimize the storage by using the MapReduce or the pick job. So if you have a lot of data in your server, and you're wanting to achieve faster searching as well, because Solar gives you the fast and efficient and powerful text searching capability. So what you can do is you can let the data come in, and you can create the indexes, and these index files are going to sit onto HDFS, and on these HDFS you can run your pick job or MapReduce job, and then this data would be organized or optimized for storage, and that can be used as the data source. That index data store can be used by Solar to serve the search requests. So in all the major Hadoop distributions like Cloudera, Hortonworks, Mapr, you can easily integrate Solar. Kapil is asking me that can leader do not serve read requests. It's generally not advisable, Kapil, because if we have the consequent write request which is coming across, then we have the preference that leader should be serving the write request. It has been preferred that leader should only be taking the write request. That is why we maintain higher replication factor to enable that the data has been highly available. If you have more number of reads expected on the application, you should have higher number of replicas. Anyway, leader is going to be anyway is going to be one only for each node. So this is how this HDFS thing is going to look like. I have data which is coming in different formats like PDF, Word, or HTML. And this data is going to go through the process of analysis and stuff. And the indexes are going to be created. And these index files are going to be stored on HDFS, the raw files. Then they go through the process of MapReduce or indexing a job. And these optimized indexes are going to be stored on HDFS as well. And from my search application, the query and the response cycle from this Solar instance, which is based out of Lucene, they're being served by these optimized index files, which are being converted by MapReduce indexing job, right? In the similar manner, we have another, implementation wherein we're using Yarn. I'm not sure how many of you have really heard of this. This is called yet another resource negotiator. So considering a system in which there is Hadoop, which is there to perform the deep analytics on the data, and Solar is there to leverage the ad hoc query capabilities, and the data is supposed to be analyzed, and it is supposed to be ingested as well from the real-time tweets or maybe say real-time RSS feeds. So that can be absorbed through maybe Spark or Storm. So you want three processes to be running in parallel. You want the data to be ingested parallelly, you want the data to be stored in HDFS, and you want the data to be easily searchable as well. So you have a data which has been ingested through Spark, and you have the data which is coming in and storing in HDFS, and you have the data which has been served as the search request through Solar. So three different processes are running. So to support this multi-purpose data processing platform, we have something which is called Yarn. So this is basically separating the resource management and the job scheduling from the data processing in a Hadoop cluster. So this is how you can use Yarn along with Solar and maybe the Spark distribution, and HDFS in a particular yarn cluster. So in other words, it basically allows you different jobs to run in a Hadoop cluster without affecting the resource management and the job scheduling. This is basically segregated. So I mean, this is something which might be more relevant to you guys. Like what is the job trend? So we are seeing a huge increase in the job trends of for Solar. So I mean, anyway, Apache Solar's scalability is unmatched. So currently, it is the most widely used search solution on the planet. We have approximately 8 million plus downloads every month, and you have approximately 2,500 plus open solar jobs. So it's been used by anyway a lot of big giants like Netflix, Apple, Instagram, LinkedIn, and I mean we anyway have seen a huge list, and it's catering to almost 100 million plus requests every day. So this is something which is very much in demand. Okay, we have before giving in the final word, I mean this is the certification which you can go for by Edureka. So we have the batch which is starting on from 24th October. So it is going to be the weekend batch. The classes happen on Saturdays and Sundays, 3 hours each day. So you have the option. I mean the batches basically run. I mean in Indian time, in morning and in evening. So it's the online live course. You have the live classes for 24 hours. You have assignments for about 25 hours, and you have the project allocation for 20 hours. Along with that, you have the lifetime access to all the resources and 24 by 7 support, which is done by Edureka. So this is something you can definitely add. You have the verifiable certificate as well, which can be added to your LinkedIn as well. So before dispersing for the day, the recording and this presentation will be made available to you within 24 hours. So you can refer to that in case you have any more doubts. Please feel free to reach us in case of any questions, queries, or feedback. Before that, we have another question from Ravindran. Does solar have any limitations? What are those, if any? Uh, Ravindran, the limitations would be on a certain perspective. So I mean, if you're wanting to achieve the search capabilities like Google, definitely this is something you can go for. The first and the only limitation I see on Solar is that Solar works on the standing data. I mean, the data needs to be stored on a particular directory or the file system, and all the analysis is going to work on that standing data, that sitting data. So I mean, it doesn't really works on the flowing data like Google. So that is the only limitation I see from my perspective. Okay. Rinky has another question. What's sharding? Is it that contains fewer info of the document? Sharding, as I just explained, Rinky, imagine you have a table data which is distributed on different nodes. I mean, the smaller chunks of a table data, which has been distributed on different places. So they all combine. All these shards, if they are going to be combined, they're going to form a single table data. So imagine you are distributing the data of a single table on different places. So that is sharding. Nishit has a question. Is it possible to form union of two documents in Solar and search on union results? Yes, you can do that, Nishit. Definitely you can do that. Krishna says, how can I use autocomplete? Okay, this is configuration based, Krishna. So had this been the real course, I would have asked you to do that. I mean, that's part of the assignment, in fact. So this is on the basis of the configuration. You can make the configuration changes and you can achieve this. And you can let the Solar decide that from where it is going to maybe auto suggest and auto complete. These are two things which you can achieve through configuration on Solar. Any more question, guys? So it was very nice interacting with a very nice bunch. I mean, a lot of things. So it was a nice knowledge sharing thing. Okay, Manoj says it was a pretty heavy seminar for me because I'm from telecom background. Okay, all right, never mind. You have the recording available to you, Manoj. You would receive it by tomorrow, so you can watch it again, maybe to digest it further. Okay, thank you, Manish. You've been a very nice audience. Yeah, thanks, Dinesh. Glad you liked the session and the demo. Yeah, thanks, Manish. Yeah, thank you, Anita. You guys have been great bunch. So thank you. You have a good night, good day. Yes, Manoj. Okay. I'm glad, Anita, you liked it. Thank you, Deepak. Okay. Good night, guys. Take care. Hope to see you in the class. Thanks. Bye bye.